time we have some Christmas break this happened. Basically just had our second Christmas break. So. Okay. Alright, so you're going to get a problem that looks like this. So it'll say, let's say y equals x squared minus 4 from -2 to 3. And I'll say find the absolute max and find the absolute min. These are very often story problems on the free response of the AP test. We'll practice them a lot, but it'll be like, there's people are waiting in line for a roller coaster. The line moves at this rate. Find when there's the most people in line and the fewest people in line. So it's the max and the min you're looking for. And so you're going to test two different types of points. So the max or min could be at -2 comma something. It could be at 3 comma something. So these are x values. So they're just giving you like a window. And then we want to compare the y values at the end. But I also want to find critical points. And I want to include critical points in this list too. So I'm going to check endpoints. And then I'm going to see if there's any critical points. And sometimes there's none. Sometimes there's a couple. And at the end of all this, I'm just going to compare the y values. The biggest y value is the max. The smallest y value is the min. So critical points here, I made this one pretty easy on purpose. What's the derivative of x squared minus 4? You guys remember that? 2x. And then you set the top and bottom equal to 0. In this case, there's no bottom, so you just set the bottom equal to 0. And your critical point here is x equals 0. So that goes in your list of things to test also. And if you got 2 critical points, you would check them both. If you got 5, you would check, you won't get 5. But you check however many there are, plus you check the endpoints. Now what do I mean by check? I mean, take these values and plug them back into your original equation. So you plug -2 in here. What do you get? It's 0, right? If you plug 3 in, what do you get? 5. And if you plug 0 in, you get -4. So then you're just looking and going, okay, that's the biggest y value. So that's the max. That's the smallest y value. So that's the min. I gave you a little sketch of the graph just so you can see what's happening. Here's x squared minus 4. That's -4. And then we're going between -2 and 3. So we're really only looking. No, that's not right. Oh yeah, so we're only looking between like here and here. And so the smallest y value is the one down there. The biggest y value is the one up there. So one happened at an endpoint, one happened at a critical. Questions? Yeah, no, your work sheet. We'll do one or two of those on there too. So let's do one that's a little tougher than that. Let's say number 2 instead of number 1. So we got like a quotient rule thing there. A little more going on. So let's say we're looking at number 2. So I know right away, we have a graph on this, which is obviously very helpful. You won't always have that, but I'm looking between there and there. So my lowest points are probably going to be these 2 endpoints over here on the side. They'll be tied. And my highest point should be this one. So I kind of know what I'm supposed to get, but you got to make sure you do the math to get there too. So kind of like my checklist over here. I'm going to check -3 and find the y value. I'm going to check 3 and find the y value. And what other types of points do I have to consider? I have to consider critical points. So I'm going to have to find the derivative. So at the top and bottom of that derivative equal to 0. And any points I get from there will also go in this checklist. So take the derivative. We could do, you have your calculators. That's still totally fair. Totally fair game, so you're allowed to just type this in your calculator. I'm just going to do it by hand because I don't think I have enough batteries to work right now. But you are allowed to use your calculator. But I'm just going to use chain rule, bring down the -1 times the 15, reduce the power by 1, and then multiply by the derivative of the inside. So that's -30x on top, and x squared plus 5 squared. Bottom. So you can type it in, you get the same thing. And then what do? So at the top and bottom equal to 0, right? So if it's on the top equal to 0, when does -30x equal 0? Well, when x equals 0. So that's a critical point. So now that has to go in my checklist. And then I'm also going to set the bottom equal to 0. Remember that squared doesn't matter. Because you would just square root both sides and get 0. And this is impossible. If I square a number, it's going to be 0 or positive, right? And then if I add 5 to an already positive number, can I get back to 0? It's not going to work. Or you can look at it this way and say, okay, well, take the square root of both sides, and then you get the square root of the negative. So that doesn't work. So we got 3 things in our checklist. What do we do with each of those things? Plug it back into where? The original, because we're looking for y values here. And then we compare. So if I plug in -3, I get 15 over 14. If I plug 0 in, I get 15 over 5, so 3. Oops. I skipped one for some reason. Then if I plug in 3, I get 15 over 14 also. So then these 2 are your mins, because they're tied for the lowest y value. There you go. And this one's your max because it's your highest y value. How many worked out? I mean, you already had some of that done. Other questions that's not what I want to know. What I want to know is this. How many feel like you understand what I just did? Okay. Other questions I can answer? Yeah. So absolute is over the entire graph. So let's say I gave you between 1 and 8. And the graph looked like this. Well, your absolute max would be this. But you've also got a relative max there. So a relative max is just locally, in its little neighborhood here, is it the king of the hill? So that's a relative max, and the absolute max is the biggest of the whole thing. So you've got the same thing with the mins. You've got an absolute min here that's the lowest. But this is a local min or a relative min because that's in its little neighborhood, it's the lowest. Good question. Oh, there's one more thing we should go over too. Look at something like this. Let's say that y value is 1 and that y value is 3. Let's say this is 1 and 3 on the x-axis. So your absolute min would be at 1, 1, right? It's the lowest point on there. Let's close that. We do it that. What's the highest y value on this graph? Because does it touch 3? So if I need to say, like, this is the actual highest y value on this graph, what would I say? So it doesn't get to 3, right? So at first you're kind of like, oh, about 2.99. Because it goes like all the way up to 3, but it never touches that 3. There's a rule of math that says no matter how close two numbers are, there's one in the middle. So if you tell me the max is 2.99, I'm going to tell you, well, what about 2.999? And then you could say, what about 2.9999? And I could say, okay, if you're being a jackass about it, what about 2.99999? And this could keep going like forever, right? But there's no end to this. So in this case, there is no absolute max. There is not a y value that you could look at and say this is the highest y value. The same thing would happen with infinity. So if this graph did that, what's the highest y value? You could say infinity. I could say, okay, what about infinity squared? You could say, okay, forgot your infinity cubed. Like we could just keep going forever, and there's not a number where I can say it stops. Yeah.
Why can't you say like 2.99 repeating?
Because it actually repeated more. That gets like the definition of repeating is like infinite, I guess. That's kind of a technicality, but the rule is no matter how close two numbers are, I can find one in between them. So no matter how close you put that repeating 9, I can go like a little bit higher. It's kind of theoretical more than like an actual, because it makes sense. So here, let me give you another. That's my graph. What is the absolute max? What's the highest y value on that graph? There's not one. So it goes to 2, but it doesn't touch 2, so we get into that 1.999 thing. If I closed that dot, what's the highest y value? 2. It's closed, it's totally fine. What's the lowest y value on this graph? What's the absolute min? There's not one. So some people will try to say this is the lowest, just because it's a dot, but aren't there total y values like way lower? And again, whatever like you say the lowest y value is, I can just subtract 1. You can subtract 1 more, and we can just keep going on forever and ever. So there are times when there's not an absolute max or absolute min. There's a couple of those on your worksheet. You see the graphs. That'll help you be able to tell. But really, you don't look pleased right now. Can I help you? This one? This one. So if you say that's higher, you're telling me there's no y values higher than that in the whole graph. But there are some higher. Like these are higher, right? So that'd be like a local max. In its little neighborhood, it's like the king. But when you look at a bigger picture, it's not anymore. Alright. So here's your worksheet. Bring questions tomorrow, and we'll keep going. Like I just got caught up to the point where I felt like we could start doing warm-ups and review a little bit more every day. 5 more snow days, and now we gotta catch up again.